Hello everyone, welcome to this 15-day sprint to JEE Main. So this is an effort from us, Vedantu, to expose all of you guys to the most probable questions which you might encounter in your JEE Main 2019. So every day you have lectures on physics, chemistry and maths at 7, 8 and 9 p.m. Is that okay guys? So that is the ultimate countdown for you all. Now, in today's lecture, we will be looking at the second part of algebra. In yesterday's class, we saw quadratic equations, complex numbers and sequence and series, which forms the first unit of algebra. In today's class, I will be discussing about matrices and determinants, which also constitute algebra. Is that okay? So, for those who do not know me, my name is Shimon Joseph and I am a graduate of IIT Madras. I have been teaching for almost 6 years now, and currently I am a master teacher at Vedantu. Okay, so when I was like you guys a few years back, even I took the JEE Mains and I was one of the state toppers, and I am also a KVPY scholar. Okay guys, so that is a quick introduction about myself, and with that note, let us get started. And what do we do now? We always look at the weightage, because some of you might have missed it, so I will give it again. So this is a weightage topic-wise analysis of the recent year's papers, which gives you an idea what to focus on. Okay guys, so as you can see here, algebra is having the highest weightage among all the chapters in maths. Okay, and that is because algebra consists of a lot of chapters, almost 8 to 9 chapters put together, and that translates to the higher percentage. Okay guys, so it is an important chapter, and if you are looking to score a very high score, I would say focus on algebra and calculus a lot. Okay guys, so let us get started for today. So I have some really interesting questions with you, which I want to share with you. It is going to be very tricky, so please pay attention to them. And if you like to try out a question, pause the video, try it out and then look at the solution. That is what I would prefer guys. Okay, so with that, let us get started for today. And this is the first question for you all. So what is given over here? So A and B are symmetric matrices of the same order, and X is equal to AB plus BA and Y is equal to AB minus BA. Then they are asking what is XY transpose equal to. They are asking what is XY transpose equal to. So what do I do here? I start off from what they asked. What did they ask? They asked me what is XY transpose. Okay guys, so let us get started with the solution of this question. Okay, so now we have it over here. I want to find out what is XY the whole transpose. And guys, if you have studied the properties of transpose, you must be very aware of the expansion of this. What is this going to be? This is going to be equal to Y transpose into X transpose. Isn't that right guys? That comes from properties of transpose. So they are asking you to pay some attention to properties as well. Okay guys, so please check out the properties of transpose and other operations as well. Okay, so now this is what they have asked. And what do we know? What do we know in the question? A and B are symmetric matrices. So if they say A and B are symmetric matrices, what does that mean? That means A is equal to A transpose and B is equal to B transpose. Isn't that right? That is the meaning of symmetric matrices. So now we will keep it aside as of now, but we will use it at one point, definitely. Okay, so let us check where we will use it and how to arrive at the answer, because this is not given anywhere, right? Does the option contain any of this? Does the option contain this one? Obviously not. It is not going to be that simple. Okay, so let us get started with solving this question. Okay, so now I would like to find what is X transpose and also what is Y transpose. So let us do that first. Okay, so I will find out what is X transpose. So X transpose is going to be AB plus BA the whole transpose. Now that can be written as AB transpose plus BA transpose. How many of you agree with me? Everyone? Isn't that simple guys? So whenever you have A plus B the whole transpose, it is nothing but A transpose plus B transpose, and that is exactly the property I have used. But guys, watch carefully, it is not yet done. It is not yet done. Why, sir? Because I still can expand this. I still can expand this. Isn't that right? Because that is exactly what I did here. When I have a product to the transpose, what do? I reverse it and transpose. So this is going to be equal to B transpose A transpose plus A transpose B transpose. Isn't that right? That is going to be my X transpose. And guys, what do we know about B transpose and A transpose? They are nothing but B and A respectively. B transpose will be equal to B. A transpose will be equal to A. That's it. So let me write that also over there. I want to simplify it as much as possible so that I arrive at my answer with much ease. Okay, so let me do that. What will that be? So this will reduce to BA plus AB. And isn't it the same as X? Isn't it the same as X? Amazing, right? So that is how they have designed the question, so that you get something very nice after you simplify everything. Most of the JEE Mains question and even sometimes advanced are designed this way, guys. It might look complicated at first, but when you simplify it, it reduces to something very easy. Okay, so now I hope all of you are clear about what I did over here. Sir, BA plus AB, how is it equal to X, sir? How did that come? Because what is X? AB plus BA. AB plus BA is the same as BA plus AB, guys. That is fine. Addition can be, you can rotate it. That's not a problem. Okay, so that is why my X transpose will be equal to X. Now there is something interesting happening here. What does X transpose equal to X mean? That means X is a symmetric matrix. That means X is a symmetric matrix. So instead of X transpose, can I write X? That's it. I got my first half of the answer. So now you have an idea. So even now you guys can pause and get the answer. So I would prefer you guys to pause it right now and try to follow whatever I did for X. The same thing you do it for Y, guys. Please do it for Y and then check it. Okay, I will solve it for you, but it is better you pause it and try it out yourself, because one time you solve, you will not forget it. You will never forget it. Okay, so please try to do that. Now I will move on to Y. Okay, I will move on to Y. Now what is Y transpose, guys? Y transpose is equal to, can you all see this? Perfect. Okay, I think it's fine. So now Y transpose is equal to AB minus BA, the whole transpose. Now that can be written as AB transpose minus BA transpose. And what is AB transpose? When you have a product, what did I say? When you apply transpose, it will reverse. So it is going to be B transpose A transpose minus A transpose B transpose. And what is B transpose? B transpose should be equal to B. Okay, so it is B and A transpose is equal to A. BA minus AB. Sir, why are you doing this, sir? Why do you want to convert it from transpose to normal? Why do you have to do that? That is because, guys, I want to compare Y transpose and Y. I want to compare Y transpose and Y. If I want to do that, my Y transpose has to simplify to AB. Okay, so that is the reason I am again changing A transpose to A and B transpose to B. Is that clear? So now I can compare them. What do you think this is? This is nothing but minus of Y. Isn't it minus of Y? As you all can see, BA minus AB. Here it is AB minus BA. So can I say this is equal to minus of Y? So what is Y transpose? Y transpose is equal to minus Y. That's it. So I will erase this and write minus Y. Okay. Yep. Now it's clear. So that will be the answer for this question, guys. You have an option which says that option C. Okay. So please go through it. I will probably pause here for a while. You can pause it, take it down, and then move on to the next question. Is that okay? So xy the whole transpose is equal to minus y into x. Okay, minus yx, and we have an option like that. So that will be my right answer, and there's no need to check everything else, guys. It is a single choice correct, and you arrived at the right choice. You did it perfectly, so it is fine. So guys, Can we move on to the next one, everyone? Can we move to the next question? Good question, right? Very simple, yet it teaches you some concept. What is that concept? Properties of transpose. So that is exactly what I want to push forward. So I'm asking you guys indirectly to pay attention to properties of transpose because you get questions from that. As simple as that. Okay guys? So perfect. We will move on to the next question. Now, this is also pretty interesting and a good question, but it has come in JEE Mains before. It has come in JEE Mains before. I just wanted to discuss it because again, it is pretty interesting and is a relatively new concept. It is a relatively new concept. We will check it out. So you guys can try it and I will start solving right now. What is given over here? We have A is equal to cos theta, sin theta minus cos theta. That is my matrix A. Now my matrix B is 1, 0, minus 1 and 1. Okay, now they are asking me to find A transpose C to the power n and A. What is C? C is something which is not defined separately. Instead it is defined with the help of A and B. So what is C? C is AB A transpose. Okay. So let me write down what this means, guys. Let me write down what this means. How will it look like? It will be A transpose into C. C to the power n, right? C to the power n means what? N belongs to integer positive. So it should be 1, 2, 3, 4. It can be anything. Okay, it can be anything because n is positive integer. That means it is going to be natural number. Okay, that means it is going to be a natural number. So what do I get from that? That is very important. So let us say I don't know what is the value of n. Let me say it is much more. It is a very high number. So let me write it down accordingly. C to the power n, right? So can I write it as C into C into C into C into C n times? N times. And then after that you have A. You have C n times. Guys, this is n times. Okay, don't tell me it's 4. I am sorry, 5. It is n times. You have dot in between. Okay. So I write C n times and in the end what is that? In the end A is there, right? A is still there. That is what I wrote here. Now, that is the basic first level interpretation of my question. Is that fine? Now, what will I do? I will write what is C. I will write down what is C because I just don't want to keep it as C because only if I write it in the expanded form, I can work around it. Only if I write it in the expanded form, I can work around it, right? So let me write it in the expanded form. It is going to be AB, A transpose, that is 1C. Then AB, A transpose, that is next C. Like that you have NC, AB, A transpose. This is the nth C. Okay, because there are n, C to the power n, right? So there are going to be C, n times. N times there are going to be C's. Put together, that is C to the power n. Okay. Now, this is first C in expanded form, this is second C in expanded form, and this is my last nth C in expanded form. Now, what is repeating, guys? If you observe here, what is repeating frequently? A transpose A, A transpose A, A transpose A, A transpose A. Everything has A transpose A. So, obviously, in my mind, it should strike that there is something that I need to do with A transpose A. There is something that I need to do for sure with A transpose A. Let me check it out. Okay. 1 second. Perfect. So now, what is A transpose? A transpose is nothing but, it is actually the same thing, I guess. Yeah. It is cos theta, sin theta. And this will be sin theta minus cos theta. Okay, is that fine? Sin theta, cos theta, sin theta minus cos theta. Perfect. Now, I want to multiply these two. So, I want to do A transpose into A. So, that means I will multiply with A. Let us check what happens then. Okay. So, guys, listen very carefully. Now, what is going to happen? Cos square theta plus sin square theta. So that will be 1. Cos theta sin theta minus sin theta cos theta. So 0. Okay, matrix multiplication, very basic. Okay, sin theta cos theta minus cos theta sin theta, again 0. And then finally you have sin square theta plus cos square theta, which is again 1. So what is A transpose A? A transpose A is equal to I. Superb, right? So you got a very good expression now. So A transpose A is equal to I. I can do a lot with that. Let us see what I can do. Now, guys, what is A transpose A? A transpose A is I. What is A transpose A here? Okay, I need an eraser. Okay. So A transpose A is again I. And then what is A transpose A here? That is again I. And similarly, everything becomes I. So what is left out? 1 second. I will just erase this also and then write it as B into A transpose A. So what is left out? It will be IB and so on. And what is I into B, guys? I into B is nothing but B only. I into B is nothing but B only because it is multiplicative identity, right? So whatever you multiply with I will give you the same thing. So therefore, it will be B times, so on. And how many B's will be there? Any idea? Let us see who is telling it correctly. How many B's will be there? For that, you need to think about how did my B come from? And where did it come from? My B comes from C alone. My B is coming because there is a C. Okay, and how many C's are there? C to the power n. So if C to the power n is there, then B also should be present n times. So the entire expression becomes B to the power n. That's it. As simple as that. Okay, guys. So now I will erase this because I will have to find out what is B to the power n. So for that, let me come this side. Okay. So B is given here. So first let us find what is B square. 1 0 minus 1 1 and you have 1 0 minus 1 1. I'm sorry. It is 1. So what is B square going to be? B square is going to be, any idea? It is going to be 1. It will obviously be 1 only because 1 0. Next will be 0 0. So it is going to be 0. And this will be minus 1. So it will be minus 2. And the next one will be 1. So guys, if I was solving this in an exam, I would not go further than this. I would never go further than this because first option, this is minus 2, right? So B square is minus 2. So I would probably guess it is 1 minus n 0 1. Okay. Let me check if there is any contradiction in the option. So first option is obviously wrong. Okay, because this should be not 1 or not 0 or not anything else. It should be minus n according to my prediction. And this is also 0 because it is 0 over here. Okay, I can probably move this around. Yeah, as you can see, it is 0 over here. And is this correct? Obviously wrong because my first 3 are 1 0 and 1. 1 0 and 1 are present. So that is not present in my option C. So what is my answer? That's it. As simple as that. Okay. Is that fine, guys? Everyone? So that is how you should solve this question. The reason I shared it is because it exposes us to a good property. Like you have to observe what is happening in the asked question and then try to use the information which you have to aid your answer. Is that fine, guys? So I hope all of you are able to follow this question and we will move on to the next question. Now this is good. You can try it out. So if you know the property associated with this question, please pause it and try it out. I would prefer that again. Now they are asking you what is determinant of adjoint of A. So I'm sure all of you know the properties of adjoint. Very important, guys. Even for advanced, adjoint properties are quite important. So please pay some time and master those properties. Okay. Now coming back to this question, they have given you A. Okay. Now they are asking you what is determinant of adjoint of A. Sir, should I find adjoint of A? Then find adjoint of A and then take the determinant? No, not at all, guys. Because if you do that, you might take probably half an hour to solve it. So they are not going to test you on calculation or speed, but rather they want to test your knowledge of properties. Okay, so let us see what is adjoint. I'm sure all of you know the properties of adjoint, right? So determinant of adjoint of A is equal to A to the power determinant of A to the power n minus 1. So this is a standard formula which you guys should be knowing. Okay, so adjoint of A, the determinant value of it is going to be given as determinant of A to the power n minus 1. Sir, what is n, sir? N is the order of the matrix. N is the order of the matrix. So let us see how to solve this question. Now, whatever I do, I need to find a determinant of A. I need to find determinant of A because even adjoint of A, I am expressing it as determinant of A to the power something, right? So I need to get an answer, and for that we should find the determinant value of this. That you can do it very easily, guys. So what is determinant of A? Determinant of A is going to be 1 into 1 plus 2 minus 2 into minus 1 minus 4. This is going to be minus 1 minus 4. Minus of 1 times of plus 1 minus 2. So it is going to be how much? Can you guys help me out? 3 plus 10 plus 1, which is equal to 14. And obviously, looking at the options, I think that is right. Okay, looking at the options, I feel what I got is perfectly correct. Now, I found my det of A. But guys, I know this formula. But what about adjoint of A? What about adjoint of A? So since I know this formula, guys, think about it very carefully. I'm going to do something really interesting here. So adjoint of A is det of A to the power n minus 1. Now, from this formula, you can still get the answer. I will tell you how. Now, can I say adjoint of A is equal to adjoint of A to the power n minus 1? Isn't that correct? Isn't that correct? Adjoint of A. So think of this as A. That should be equal to det of A to the power n minus 1. Okay. Adjoint of A. Think this entire quantity as A. That will be equal to A to the power n minus 1. That is exactly what I have written here. Okay. But for this, you need to remember one thing. A and adjoint of A will have the same order. That is something we have to know. Otherwise, you cannot do this directly. Okay, guys. So A and adjoint of A are going to have the same order. That property I know, and that is why I wrote this result. Now, it is adjoint of A to the power n minus 1. But I know what is adjoint of A. What is adjoint of A? Det of A to the power n minus 1 to the power n minus 1. So, can I write this as? Over. Done. Okay, guys. So, that is how you solve it. So, what is given here? Adjoint of A to the power n minus 1. Now, adjoint of A I know, right? It is det of A to the power n minus 1. Det of A to the power n minus 1. So it is going to be det of A to the power n minus 1 to the power n minus 1, which will become det of A to the power n minus 1 square. And what is n minus 1? N is 3 cross 3, right? N is 3 cross 3. So n is 3 means n minus 1 will be 2. N minus 1 will be 2. So my answer is going to be det of A to the power 2 to the power 2, which is 4. So our answer is det of A to the power 4. And what is that going to be, guys? Everyone? Did you get the answer? Perfect. All of you are right. That is exactly correct. 14 to the power 4 will be my answer for this question, which is option A. Which is going to be my option A. Is that okay? Everyone comfortable? So again, the takeaway from this question, guys, only note the takeaways from the question. No need to know the answer or no need to note down the steps. The takeaways are very important. That is what the ultimate aim is. Okay, to give you some important takeaways. So here I would say this rule is a good takeaway. This rule is a good takeaway. That's it. That is enough. In this question, the last 10 minutes, what we did, only these two relations are important. Okay, so now I hope it is clear. If you have any doubt, please rewind it and go through it again, guys, and try to simultaneously read some properties side by side. That is better. Okay, when I try to solve questions, you keep some notebook or reference book by your side and try to recollect what I am discussing over here. That will be super useful, guys. Okay, perfect. Now we will move on to the next one. Now this is again a very good question. Please try to solve it. Please try to solve it. Okay, So now what have they given here? They have given if a minus 2b plus c is equal to 1, then they are asking you what is the value of this determinant over here. So what is the relation I know? The relation that I know is a minus 2b plus c equal to 1. Guys, don't think it's an AP. It is not so. They have given a minus 2b plus c equal to 1. Okay. Therefore, it is not in AP and all. Because the similar question is there in NCERT, wherein A, B, C are in AP, you try to do something and then determinant value becomes 0, right? So don't do that over here because clearly they are not in AP. Now, with that understanding, I will start solving my question. Now, what will the first step be? So I noticed that this number in the middle, is the average of first row and last row. Because 2 is nothing but 1 plus 3 by 2. Okay. So now what will I do here? Any idea? So what I do here is I will change R1 to R1 plus R3 minus 2R2. Okay. So such a change is allowed because this is determinants, right? We can do such changes. Now let us come back to solution of this. Now what is R1 plus R3? It will be 2x plus 4. 2x plus 4 minus 2 times of x plus 2, which is going to be 0. Isn't that superb? So that is the observation you should do when you start a determinant question like this. When you start a determinant question which asks you to find the value, you have to think on these lines. You have to bring maximum zeros as possible. That is my intention here. So I got 0 here. Now, what do you think the second term will be? What do you think the second element will be? That will again be 0. So I got 2 zeros in one shot, which is super amazing in an exam like this. Okay. Because almost done, guys. The question is almost done. Let me show it for you. Okay. Now this is going to be 2x will get cancelled. It will be a plus c minus 2b. It will be a plus c minus 2b. But what is a plus c minus 2b? A plus c minus 2b is given to be 1. It is given to be 1. That's it. So I'll erase this also. It's going to be 1. That's it. Now write the entire matrix. So it is going to be, determinant. Okay. So that is my value of the determinant. I will open it now. So if I open it, what do you get, guys? It's going to be 1 into x plus 2 into x plus 4 minus x plus 3 the whole square. Is that correct? It is going to be minus x plus 3 the whole square. Let us do it. So x plus 2 into x plus 4 will be x square plus 6x plus 8 minus x square minus 6x minus 9. So what is my answer? My answer is going to be minus 1. Is there a minus 1 in the option? Guys, minus 1 is there in the option. So that will be my answer for this question. Is that fine? Everyone? So I will tell you guys slowly what I did here. So first is this change. This change is very important. Okay. So this is a change which I do initially. Now when I do this, what happens? R1 plus R3 minus 2R2. So it will be 0 first. Then second also will be 0 because when I do this, it will be R1 plus R3, which is 2x plus 6. 2x plus 6 minus 2 times of x plus 3, which will be 0. That is exactly what I wrote here. Similarly, this if you do, it will be a minus 2b plus c. It will be a minus 2b plus c. And what is a minus 2b plus c given to be? It is given to be 1. That is exactly what I wrote here. Is that fine? And then all the other things I left as it is because I am happy with the 2 zeros. I am really happy with the 2 zeros because I know my answer is done. My answer is almost done because I got 2 zeros. Now let me expand it. If I expand it, what do? I multiply these two and subtract these two. So what is x plus 2 into x plus 4? X plus 2 into x plus 4 is going to be x square plus 6x plus 8 minus x plus 3 the whole square. What is x plus 3 the whole square? X square plus 6x plus 9. That is what I subtracted. So these two will get cancelled out. So it will be 8 minus 9. And what is 8 minus 9? That is my option C. Is that fine? Good question. Very simple. Again, uses the properties of determinants to reduce it, to bring in more zeros. Okay guys, so let us quickly move on to the next question. Now, please try to solve this one. Please try to solve this one. Again, a very interesting question. So what are they asking? They are asking the number of positive integral solutions. Guys, very important to pay attention to what they have asked. Very, very important. What they are asking? Positive integral solution. What do you mean by positive integers? Nothing but natural numbers. Nothing but natural numbers. So they are asking you, what are the natural number solutions of this equation and how many such solutions are there? How many such solutions exist? That is the question, and let us see how to solve this question in an effective way. Okay, perfect. Let us get started, guys. So here, what do I do? What do I do? So in the first row, if you observe, you have y cube plus 1, y square z, y square x. Okay. Now, second row, what do you have? yz square, z cube plus 1, z square x. Now let us look column wise. In this in the first column, second and third row, in the first column, second and third row, y is common. Isn't that right? Y is common. So if I want to take y out common, then I need to have one more y in the first row. Okay, I need to have one more y in the first row. So what I do is, guys, listen very carefully. I'm going to do something here. What I do here is, I will multiply by y to the first row. I will multiply by z to the second row, and I will multiply by x to the third row. I will tell you why. Okay, let us observe it. So it will be y into y cube plus 1. Okay, and then you'll have y cube z, and then you'll have y cube x. Now I will multiply by z to the second one. So it will become z into z cube plus 1 into z cube x. Now third row I will multiply x. I will multiply by x to the third row. So what did I do? Multiply by y to first row, z to second row, x to third row. That is what I did. And since I multiplied, what should I do? I should also divide, right? How can I just multiply? That is not allowed. Now watch carefully. Can I take y common? Didn't I say that? So can I take y common from this? Yes, absolutely. I can take y common from this. I can take z common from second column, and I can take x common from third column. I can take y from first column, z from second column, and x from third column. Let me do that. And when I do that, what happens? X, y, z will come out as common. I can remove these things. And then we'll have x and x cancelled out. So now I will remove this. Perfect. Now this is what I am left out with. This is exactly what I am left out with. So guys, let us see how to solve this question now. Okay. So what do I do now? Any idea? What do I do now? It becomes a very simple determinant based question. So first let me rewrite this because there's a lot of confusion here. One second. I will erase the x. Okay. One sec. Okay, very careful. Okay, and then this z over here. Yup, done finally. Okay, so this is my expression which is left over here. Okay, this is my expression which is left here. So as you can see, I have y cube on column 2 and column 3. So first thing what I might do is I might subtract column 2 and 3. Okay, I might subtract column 2 and 3. So C2, let it be C2 minus C3. So if C2 is C2 minus C3, what happens? I can bring 0 here because y cube minus y cube is 0. And z cube plus 1 minus z cube is going to be how much? It's going to be 1. And x cube minus x cube plus 1 is going to be minus 1. Okay guys? So it is going to be minus 1. Now, I am not happy with this. I want to bring in more zeros. So let us see where I can do that. Now, what do you think can be done? Can I change C3 to C3 minus C1? I can do that, right? I will change C3 to C3 minus C1. So what will happen here? This will become y cube minus y cube plus 1, which will be minus 1. And then z cube minus z cube will be 0. And then x cube plus 1 minus x cube will be 1. Okay, that is going to be 1. Okay, perfect. Now we have got something very nice. So now we have almost arrived at the answer, guys. So this is my final expression. Let me open it now. So what will that be? That will be y cube plus 1 times of 1 minus 0. That's it. 1 minus 0. And this I can't open it because it's 0 anyway. Now the third one, when I open it, what do I write? I will write minus 1 times of minus z cube minus x cube. So it is going to be minus z cube minus x cube. So which is going to be x cube plus y cube plus z cube plus 1. Okay. Superb expression. So such a complicated expression reduced to this one over here. Now you will see the magic happening, guys. It is a super interesting question. Okay, so what can I say? X cube plus y cube plus z cube plus 1 is equal to 11. Okay, so now can I say x cube plus y cube plus z cube is equal to 10? And what did they say? They said that x, y and z are positive integers. That means they have to be natural numbers. And in natural numbers, when can this happen, guys? This can happen only when it is 1 to 1. So 1 cube, 1, 2 cube, 8, z is 1, right? So 1 cube is going to be 10. So only this possibility is allowed. Only 1, 2 and 1 can be allowed. But what takes 1? What takes 2? What takes 1? Again, we don't know that. So it can be 1, 2, 1. It can be 1, 1, 2. Or it can be 2, 1, 1. Okay, so these are the three possibilities which are there. That means x can be 1, y can be 2, z can be 1. Or x can be 1, y can be 1, z can be 2. Or x can be 2, y can be 1, z can be 1. Is that okay? So that is exactly what I am trying to say. Or if you want to do it other way, you can do it by this method. Okay. What is that method called as? Permutation and combination you have learned, right? There are three objects. How many ways can I permute them? That is going to be 3 factorial. But 2 are identical. So my answer is going to be 3. You can do it that way also. That is also totally fine. Either this or that. You should be clear. Okay, guys? And why did I write this as 1, 2 and 1? Because they are natural numbers. And their sum of the cubes is equal to 10. It can happen only when x is 1, y is 2, z is 1, or such combinations. Okay, only 1, 2 and 1 are possible. Is that fine? So that is why I wrote it this way. So the answer is going to be option C. Option C is my correct answer for this question. So good question, guys. So I hope all of you liked it. And in case you did not get it, please rewind it and watch it again. Okay, so we will move on to the next one. Okay, now guys, this is the special part which I spoke about. And let me tell you, the next 10 minutes if you listen carefully, I can guarantee you will get 4 marks. Because for the last 5 to 6 years, we have been getting questions from this concept. Under determinants. What is that concept, sir? System of linear equations. You must have seen, right? They'll give you 3 linear equations and they'll give some variable in it. And then they'll ask you to find the range of values of that and so on. So let me teach you the way to solve such questions. So please be careful and be attentive and let us try to master this concept. Okay guys? Perfect. So let's start it. Now, I have system of linear equation. What do you mean by that? We have studied system of linear equation right from 10th standard, right? Solve simultaneous linear equation in 2 variables and so on. Like that, you might have system of linear equation in 3 variables also. Now, whenever you have a system of linear equation, we are always interested in solution. We are always interested in finding out the solution. Is that correct? So now, I want to understand what is the meaning of consistent solution, what is the meaning of inconsistent solution, and what is the meaning of dependent solution. Is that fine? Now, what do you mean by consistent solution? Consistent solution means you have a unique solution to the problem asked. You have a unique solution. For example, let me give you an example. So now they are asking you the point of intersection of 2 intersecting lines. So for example, if you have 2 lines like this, what is the point of intersection? Only one point, this one. So that is called as consistent solution or unique solution. Why? Because these 2 straight lines are nothing but linear equations, but they are meeting at only one point. That means only one point is my solution. That is going to be unique. And such cases are called as consistent solution or consistent system. So these 2 equations, right? Line 1 and line 2. Those 2 equations, I call it as a consistent system. Why do I call it as a consistent system? Because it has a unique solution, as simple as that. Okay. Now, coming to inconsistent solution. Inconsistent, as you can see, it is defined directly, right? Okay. So it is defined directly as no solution. I don't have any solution to that. What is an example? I am sure most of you must be knowing this. The example for inconsistent solution or inconsistent system is going to be a pair of parallel lines. So as you can see, these 2 parallel lines, will they have any solution? These 2 parallel lines, will they have any solution? No, not at all, because they do not intersect. They do not intersect. If they do not intersect, how can I have a solution? Therefore, these two lines form a system of inconsistent solution. Okay, I mean inconsistent system of equation. So these 2 parallel lines, when I put them together, it forms an inconsistent system. Okay. Now coming to the last one. So last one, in many books, guys, please pay attention to this. Many books, last and first are usually combined. Okay. In many books, the last and first one are usually combined. They usually call it the same. Because in dependent, what you have? You have infinite solutions. It is not like solution is not there, but you have infinitely many solutions. You have infinitely many solutions. What is the example of that? What is the example of that? 2 coincident lines. So I have a line like this and I have one more line on top of it. So how many solutions do I have? I have infinitely many solutions. So that is the last case, which is called as dependent system. Okay guys. So now some books, they say dependent and consistent as the same thing. They say dependent and consistent as the same thing. Okay. So please be very careful while reading. Don't get confused. Okay. Perfect. So now we will move to the next part, or move further into detail. Okay. Move further into depth of this particular concept. Okay guys. So now I have system of linear equation in 3 variables. I have a system of linear equation in 3 variables. So this is my system, guys. This is my system. I have 3 equations, 3 unknowns. So it's a normal 3 variable equation. Now I define something as delta. Okay, let me move this here. I define something as delta. What is delta? Delta is A1 B1 C1, A2 B2 C2, and A3 B3 C3. Guys, this is C2. Okay, I think that's a printing mistake. This is C2. So that is my delta. I define it that way. And what is delta 1, delta 2, delta 3? Guys, listen very carefully. Delta 1 is replacing the first column with D1, D2, D3. That's it. So delta 1 is nothing but replacing the first column of delta with D1, D2, D3. That's it. Over. Okay. So that is exactly what I'm doing. Now, based on this, can you tell me what is D2? Can you tell me what is delta 2? Anyone? So delta 2 is nothing but replacing the second column of delta with d1, d2, d3. That's it. Now the same way delta 3 is nothing but replacing the third column of delta with how much? d1, d2 and d3. That's it. d1, d2 and d3. So here delta 3, how do I do it? I have delta in the third column, I replace it with d1, d2, d3. Over. As simple as that. Okay. Now right now it may not make sense, but it will in some time. Okay guys, so let me do that for you. Let me explain it for you. Now I will take delta 1 alone. Let me simplify it further. Delta 1, okay, delta 1 is going to be, I'm sorry, it is not b1, it is d1, d2, d3, right? So d1, can I write d1 as a1x plus b1y plus c1z, okay, and can I write this as a2x plus b2y plus c2z, and similarly d3 I can write it as a3x plus b3y plus c3z, and this is going to be b1 c1, b2 c2 and b3 c3. Okay, perfect. So that is the expansion of delta 1. I just expanded delta 1 in this fashion. I will tell you why. It will make sense in a while. Okay, so now I will simplify it further. What I'll do is I will use property of determinants. When I know there is a sum in first column, I can split it. I can split the determinant. So that is exactly what I'm going to do. Guys, can I write it as is this fine? I wrote it like this. Plus what do I have? I will have b1y, b1c1, b2y, b2c2, b3y, b3c3. Is that correct? I will have one more. Plus c1z, b1c1, c2z, b2c2, c3z, b3c3. That is also there. I don't have space, that's why I didn't write it. But let me tell you something here. Can I take y common? Can I take y common outside? But if I take y common outside, what is happening here? Column 1 and column 2 are the same. Column 1 and column 2 are the same. So what will happen? The determinant value will become 0. 0. That's it. Super amazing. So now, after I do that, let me show the last one also. So last one, what did I say? It will be C1Z, B1C1, C2Z, B2C2, C3Z, B3C3. Okay. So now in this one what happens? Now I have C1Z, C2Z, C3Z. So can I take Z common out of this? Can I take Z common out of this? Now if I take Z common out of this, what happens? First column and last column are the same. First column and last column are exactly the same. So what will happen? They will become 0. They will become 0. That's it. Over. So my delta 1, which was like this and it came out to be so big, is now reduced to such a simple one. Can I take x common from this? Can I take x common from this? If I take x common, what is inside? A1, B1, C1, A2, B2, C2, A3, B3, C3. And what is this determinant called as? This determinant is called as delta. Isn't that right? This determinant is nothing but delta over there. Can you all visualize that? Okay. So delta 1, which reduced to this one, can be written as delta 1 is equal to x times delta. Do you all agree with me? That is exactly what I wanted to derive. I hope all of you are clear with this. Because delta 1 is this expression and that is equal to x times of this is delta. That's what I wrote there. Okay. Perfect guys. So let me erase all this now. It is done. Let me erase all this. So what do you think will be delta 2? Delta 2 will be y delta and delta 3 will be z delta. So what is x? That's it guys, over. X is equal to delta 1 by delta. Y is equal to delta 2 by delta, and z is equal to delta 3 by delta over. Done. As simple as that. Okay, I'm sure some of you would have already done this, and this might be a repetition. It's totally fine, guys, because this is quite an important concept. For those who do not know, I hope you got something from here. So please try to build on that, go and capitalize this and exploit it completely. Okay, guys, so solve some questions. And if you don't have any resource, the best place I would say is previous year's JEE Mains papers, because you have plenty of questions on this concept. Plenty. Okay, it is not yet done. Now I have just derived the solution. What is x, what is y, and what is z. Now this is called as Cramer's rule. This is called as Cramer's rule, which you might have studied in 10th standard. In 10th standard, do you guys remember, while solving simultaneous equation in two variables, what do? We try to cross multiply. You would have called it as cross multiplication method, you remember? So that is called as Cramer's rule, but that time we did it for two variables. Now we are doing for three variables. That's the only difference. Okay, guys? So I hope this concept is clear. Please keep these three things in mind. Please keep these three results in mind. It is quite important. I will tell you why. Is that fine? I hope all of you have understood this. We will move on quickly. Now, I have derived the same thing for you here. I have just derived the same thing here. Okay. So here you have x, y and z obtained in terms of delta 1, delta 2, delta 3 and delta. Okay. So now this is the important part. This is the most important on which you will be tested. This is the most important part on which you will be tested. So let us try to see slowly what is happening here. So they are asking you nature of solution of system of linear equations. Nature of solution of system of linear equation. Okay. Let us try to see what is here. Now guys, watch carefully. So I know my x is equal to delta 1 by delta. Okay. So if my delta is not 0, then I always have unique solution. So if my delta is not 0, my x, y and z will all be defined, because denominator is not 0. So I am happy. I am really happy about it, because now x and y and z will be unique. Therefore, I will have a unique solution, that is case 1. What is case 1? Case 1 is nothing but delta is not equal to 0, then the system will have unique solution to it. That is it. So if they give you a question, this system has a unique solution, immediately it should strike you that delta is not 0. As simple as that. Okay. So whenever they say unique solution, delta is not 0. Okay, guys. So now we will move on to the second case. Now what will happen if delta is 0, sir? I want to understand that. What will happen if delta is 0? Now I will write it in a different form. Just watch this, guys. So can I say delta 1 is equal to x delta? Okay. And delta 2 is equal to y delta. And delta 3 is equal to z delta. Okay. So now I will tell you one thing. Please listen very carefully, guys, because these are very important concepts. So I would require your 100% attention here. Okay. Now delta 1 is equal to x delta. Okay. So they are saying delta is 0. Okay. If delta is 0, what happens to my right hand side? My right hand side is 0. Now if it happens so that my left hand side is non-zero, does solution exist? Can it be possible? So that is the case for no solution existing. That is inconsistent system. Let me repeat it again for you. Please listen carefully. Now I am looking at the case wherein my delta is 0. That is my case. So right hand side is 0 here, right hand side is 0 here, right hand side is 0 here. Okay. So that should imply that delta 1, delta 2, delta 3 all are 0. But what happens if one of them is non-zero? What happens if at least one of them is non-zero? What will happen? Then you have no solution, because your right hand side is 0, and how can your left hand side be non-zero? So that is the condition for inconsistent system. Let us look at it here. If delta 1 is not equal to 0, then left hand side is non-zero, but right hand side is 0. How is that possible? That is not possible, right? Left hand side non-zero, right hand side 0. Then how can you say it is equal? So that is why no solution exists. So if any one or more of delta 1, delta 2 and delta 3 are non-zero, then you don't have any solution. But guys, before you come to this condition, what is the previous one? Previous one is delta equal to 0. Okay, think about that first and then come here. Okay, not the other way around. Okay, always come from delta equal to 0 and then check this. Okay, that is the procedure to follow. Now, if any one of them turns out to be non-zero, then you have no solution and the system is called as inconsistent system. Okay, is that fine? So now we will move on to the next part, which is the infinite solution case. So here it is pretty simple. Now you must have got the hang of what I am discussing. So x1 is equal to, delta 1 is equal to x delta and delta 2 is equal to y delta and delta 3 is equal to z delta. Now this is what is given to you, right? In this case, it is again under case 2. It is a subdivision of case 2. What is case 2? Case 2 is delta being equal to 0. That means what? My right hand side is 0. This is 0, this is 0 and this is also 0. Okay. These three right hand side are 0. Why, sir? Because delta is 0. X into 0, y into 0, z into 0 is obviously 0. Now, in this case, my delta 1, delta 2, delta 3 are also 0. My delta 1, delta 2, delta 3 are also 0. So, what does that mean? That means 0 is equal to 0. So, before I even think of x, y and z, it is already satisfied. Before I even think of x, y and z, my LHS is equal to RHS. That means what? It does not depend on x, y and z. Whether you put any value of x or any value of y or any value of z, it is already satisfied. Okay, it is already satisfied because my left hand side is 0 and my right hand side is also 0. So x can take infinitely many values. Similarly, y can take infinitely many values. So that is my it is consistent system with infinitely many solution. Okay, it is called as a consistent system because it has solution. It has solution, but infinitely many in number. Is that clear, everyone? So that will be the end of theory. We will go to a problem now. And this is the problem which I have for you. So in case you guys understood everything clearly, I would again suggest you to pause it here and try it out on your own. Okay? Perfect. Good job, guys. So I think we have almost come to the end of the session. So with this one, we will complete determinants, and I'm sure you guys will go back and work a lot on this so that these 8 marks, guys, I'm not sure whether you know about this. Matrices and determinants almost have 3 or 2 questions coming every year. So 8 to 12 marks is in your hand from today's topic. So revise whatever I have covered as the important concept right now and today itself, because we don't have much time. Okay, guys, perfect. So let us come back to this question. So let P denote the set of all values of lambda for which the system of equation is inconsistent. What is inconsistent? The last case which we saw. So you guys must remember that. Okay. So last case, if it is inconsistent, what are the conditions? Let me write that down first. Okay. So if it has to be inconsistent, the first thing is delta should be 0. That is my first condition. If it has to be inconsistent, delta must be equal to 0. Okay. What is the second condition? Any one of delta 1 or delta 2 or delta 3 must be non-zero. So that is my condition for inconsistent system. Okay. So I will keep that in mind. Now let me get solving. So what is delta? Delta is equal to lambda 1 1, and you have 1 lambda 1 and then you will have 1 1 lambda. So when I open this, what do I get? Lambda cube minus lambda minus 1 times of lambda minus 1. minus 1 times of lambda minus 1 plus 1 minus lambda. So if you expand it, what do you get, guys? Delta is equal to lambda cube minus 3 lambda and plus 2 equal to 0. Because delta should be equal to 0, right? Delta must be equal to 0. That is what I have here. So this delta which I got must be equated to 0. So if you reduce this is nothing but lambda minus 1 the whole square into lambda plus 2 is equal to 0. So if you reduce this cubic equation, because 1 is a root, right? If you put 1 minus 3 plus 2 is 0. So using synthetic division, you will get this to be the result. So what can you say? You can say that lambda can be 1 or lambda can be minus 2 to make my first condition true. To make my first condition true, lambda can either be 1 or lambda can be minus 2. Okay. So let that, we will have it like that. I will remove all this. Now, my second condition is any one of delta 1, delta 2, delta 3 must be non-zero. Any one of delta 1, delta 2, delta 3 must be non-zero. Guys, think about it. If I put lambda as 1, then delta 1, delta 2, delta 3 will always be 0. It will always be 0. Because what is delta 1? Delta 1 is first column alone I change. Second column is going to be, first column will be 1, 1, 1. Okay. And lambda is 1, right? So it will be 1, 1, 1, 1, 1, 1. So what is the determinant value of this? The determinant value of this is going to be 0. So whenever lambda is 1, delta 1, delta 2 and delta 3 become 0. You can check it out. How do I write delta 1? Delta 1 is nothing but first column of delta I replace with these 3. First column of delta I replace with these 3. So it will be 1, 1, 1 and it should be 1 lambda 1. But lambda is 1, right? That is what we are trying to check. So lambda I put as 1. Okay, lambda I put as 1. Now third column will be 1, 1 and lambda. So this should be lambda and lambda we have taken to be 1. That's what I have put here. But what is the value of this? The value of this is going to be 0. Okay. The value of this is going to be 0. And similarly, delta 2 also will be 0. Delta 3 also will be 0. Okay. So what if delta is 0 and all 3 are 0? What if delta is 0 and all 3 are 0? It comes under the case of infinitely many solutions. It comes under the case of infinitely many solutions. Therefore, I do not want to include lambda equal to 1. Lambda equal to 1 is wrong. It is not going to be part of my solution. So lambda is going to be minus 2. Lambda is going to be minus 2. And for that, it will work out. So there is only one value of lambda which is possible, and that is equal to minus 2. So the answer for this question, can you guys tell me? It is going to be option A, because they are asking you summation of modulus of all the values of lambda. They are asking you summation of modulus of all the values of lambda. So what is that going to be? That is going to be modulus of minus 2, which is 2. So option A is correct. Is option B correct? Obviously option B is not correct because lambda is minus 2. So we can't say that. And cube roots of lambda are 1 omega and omega cube. 1 omega and omega square. What does that mean? That means they are indirectly saying lambda is 1. They are indirectly saying lambda is 1. But we just saw that lambda cannot be 1. So option D is also wrong. Now option C, they are saying x tends to lambda mod of x plus 2 by x square minus 4. That is also wrong. You guys can check it out yourselves. Because my LHL and RHL will be different. About lambda. Okay. Because as you can see here, it is mod of x plus 2, right? Mod of x plus 2, where will it split? It will split at minus 2. Isn't that right? Mod of x plus 2 will split exactly at minus 2. Therefore, my LHL will be different, my RHL will be different, and so they are not going to be the same. And therefore, this result is wrong. Okay, guys? Perfect. So with that, we come to the end of this session. I hope all of you learned something great from today's session. And guys, it has a very high weightage, and in my opinion, these are easy topics to score marks. These are very easy topics to score marks because you just need to remember the set of formulas. So I would like to talk about some important points to focus on. Okay, the first one is going to be properties of matrices. Okay, I want you to study properties of adjoint, properties of transpose, and then I want you to study what is cofactor matrix. It is always good to keep all these things in mind. Okay, even properties of inverse is quite important, guys. And then please keep the value of determinant of A inverse, determinant of adjoint of A, determinant of adjoint of A. These results, it's better to keep it in memory so that it will come very handy in exams. Okay guys, so that is about matrices. Coming to determinants, there are two parts which I want to focus on. One is going to be properties of determinants, how to solve a determinant, how to bring in zeros. That is going to be one side. The next part is solution of system of equations. Guys, solution of system of equations is pretty simple and you get sure shot one question from that. Sure question from that. So please master those topics right now and today itself. Okay, so please practice some questions, and the best resource is always the previous year's papers. So last 5 to 6 years papers is a good resource. Try to attempt those questions based on what you learned today. There is one more part which I didn't cover in today's session, which is going to be solution of homogeneous equation. Solution of a system of homogeneous equations is something which I didn't cover. So please try to read it on your own. Okay guys. So in case you found it useful, please do give a like and subscribe to our channel as well, and share it with your friends so that all of you can learn together and benefit from this effort from our end. Okay guys, so see you tomorrow in Algebra 3. Practice a lot, work very hard, and come out with flying colors, guys. That is exactly what we want all of you to do. Okay, see you, bye bye.